It's like
That's another
less than you got 5 minutes. Just first on the country.
you just like assume. Thank you.
You're welcome. If it wasn't Cadbury, you're not a deal.
Hey, look up. Okay, so this question comes up every year. It's very common.
Wait, I think I figured it out.
Oh, please.
Is it because it's always going to be positive, and so you don't need the absolute value?
Nicely done.
Yeah.
Yeah. So either answer is actually
What the
fine.
heck, Hadley?
But they did exactly what Hadley said. They said, hey, wait a minute. E to some number is always a positive value. Adding 3, still positive always. Hence, absolute value of a positive doesn't do anything. So they just threw them off. Same thing here.
So can I just put them on every time? Because
Either way is fine.
I don't.
There will be some problems in the future where recognizing what Hadley just recognized is helpful to get rid of the bars. So make sure this makes sense. Pretty good?
Wait, so are E's, were there E's negative?
What's that?
Are E's only negative if there's negative?
Now remember, E is just a number.
Yeah, I
0.7.
mean, like E's 2. But
Oh, right. Think of it this way, Brennan. If I take E to 6, that's 2.7 to the 6th, that's positive. But if I take E to the negative 6, that's the same thing as 1 divided by E to the 6th. E to the 6th is positive, so 1 divided by a positive is still positive.
so it's only negative if there's negative in front of that.
Right, then it's negative times something. So yeah. 2 points for Brennan. Okay, guys on me. Okay, tonight's homework, there are 18 problems in the pink packet. We're going to do about 5 or 6 of them together, so you'll only be left with about 12. There are a couple of new ideas, but they're not like big steps. They're just little steps. So for those who are struggling with U substitution, we're going to do that again today. So ask as much as you look. Ask as much as you need to ask to get comfortable with it. But the only way you can learn it is to just dig in and try. And then if you get stuck, you ask, and I'll help you. But you just got to kind of fight your way through it. But you can ask as much as you want to ask. So, anyway, so grab the pink packet. Go to number 1. Again, don't do any of the work in the packet. Do it in a notebook. Okay. One new concept for today is you now are looking at an integral. You've seen these before, but in the past you would have just picked up your calculator, typed it in, found the result. Okay? Today we learned how to evaluate the integral without a calculator. We're working in that section of the test right now, the non-calculator section. So the way we can evaluate this is described by the fundamental theorem. So on your paper, you've already written this down. Write down over here, let's see, the integral from 0 to 8 of f prime. According to the fundamental theorem, that integral's value is equivalent to the function f, not f prime, evaluated between 8 and 0. So as we've said many times, if you integrate the rate at which f is changing, you will find out how much f actually changed. So this is the fundamental theorem. It's not new. Questions to hear? Okay, one new idea is just notation. There's an alternate way to write this theorem. Instead of writing f of 8 subtract f of 0, you can write f of x bar 8 and 0. And it means the same thing. So it's a shortcut way of writing it. So this means take f of x, plug in 8, plug in 0, and subtract them. So these are the same thing. Just a different way of writing it that we're going to use today. Please.
So is the f prime dx like in place of the dx over square root of 1 plus x?
So what I'm doing here is, this is the general case, meaning this would apply for any situation.
You would just tell me.
No, you're awesome. So now I'm going to apply this to this situation. So basically what I'm thinking is, oh, I get it. This is, let's rewrite it like this. Let's see, let's go 0 to 8. Let's put this on your paper. 1 over square root 1 plus x multiplied by dx. And what Brendan is saying correctly is this that's f prime. It's not technically f prime. I'm just thinking of it as f prime so I can fit it into this situation. Because I want to find the value of the integral, and the fundamental theorem says if I want to integrate f prime, I just need to find f. So it's not like it's technically f prime, it's just some formula. But it does now match with this. 2 points for Mike.
Do you just plug the f of 8 for x and then minus f of 0?
Yes, but I have to find the formula for f first. So I'm thinking of this as being f. Remember, this has to be f prime, this has to be f. So I'm thinking, hey, if this is f prime, I need to do what Hayden said, 2 points. I need to go find f. So someone, how is f prime related to f?
Do you just take the derivative of it at x equals 8 and x equals 0?
So backwards. No worries. Think of this as f prime.
Oh, yeah.
We need to find f, so we got to go antiderivative.
Oh, yeah.
That makes sense?
Yeah.
2 points. So I need to find the antiderivative of this. Wade, if you need me to go through that again, I'll be glad to do it as many times as you need. Okay, cool. So we're looking for the antiderivative of this thing. So that's where it becomes last night's homework. Square root, I don't deal with those, so I'm going to change that to a power. So on your paper, write this. 0 to 8, 1 over 1 plus, I don't like writing 1 plus x either. All my formulas are the other way around, x plus 1, so I'm going to switch that. Question? Cool. So now, let's see. I need to find this antiderivative because I'm thinking of this as being my f prime. Pretty good? Okay. I don't have a formula that fits this because I can't use the log rule because that's 1 over, well, there's the extended log rule that's close. You look at, get your green sheet in front of you. The extended log rule says 1 over ax plus b. But it doesn't allow for 1 over ax plus b to a power. So I don't want to do that. Mikhail.
Never mind.
No, no.
Square root isn't helping. It was like, since it's a square, can't you just do 2? Like split it into 2, but it didn't work because it's not.
No, it's a good question, but
Yeah.
no, you're fine. 2 points. Let's go, Brendan.
You're going to flip it to the top.
So move it to the numerator. How many knew that before he said it? 2 points. So we go 0 to 8. Hey, make sure you have good notation. The problems are getting complex enough now that if you don't have good notation, you'll lose points quickly. So equal, write exactly the way I write it. Let's see, so this becomes x plus 1, negative 1/2. Questions? Cool. Oh, please.
Didn't you just keep the antiderivative?
No, all I did was algebra so far.
Oh, yeah, but then after.
Oh, yes, now we can do the antiderivative. Because the ax plus b version, the extended power rule, fits this exactly. You need to talk more about that. Cool. So your next line says, so remember this blue here, this is my f prime. But now I'm finding the antiderivative of this, which is what I'm referring to as f. So we would get, let's see, it's 1 over a multiplied by ax plus b. The a is a 1. So that's x plus b to the 1/2 plus 1 divided by 1/2, negative 1/2 plus 1. So this is no longer f prime. This is now f. So change color. Ooh. So that's my f function. Please.
Is that all the notation you do from going from the integral back to the...
We need one more thing. We need the bar. So think of it this way, too, for Elijah. Prior to finding the antiderivative, we still have the antiderivative symbol. Now that we've found the antiderivative, we don't have that anymore. It becomes a straight line. Let's go here.
What about this?
Oh, we'll worry about that in a minute, but no worries. Don't let me forget if I don't address that. Is she good here? Please, Allison.
So, sorry, but
You're fine.
when you multiply, so when you do when you're taking the antiderivative, you add 1 to the negative 1/2, wouldn't the number in front of the x be 2? Because then
Right here.
yeah,
So the rule says you have ax plus b
yeah.
to the n, and it becomes 1 over the a, so 1 over 1.
Oh, okay.
Is that your question?
Yeah.
Point. Awesome. So let's go, let's see, here now. One over 1, that's easy. Okay, negative 1/2 plus 1 is
1/2.
1/2. But dividing by a half is the same as multiplying by 2. So I'm going to write equals 2. What's this exponent say? 1/2. Exponent of 1/2 means square root. So I switch back. So let's see, square root, x plus 1. And that needs to be evaluated from 0 to 8. This one you can actually check fairly well. We won't worry about that. We good to hear? Okay, please. Say it one more time. Oh, no worries. 2 points. So all of it's being divided by a half. But if I have something like this, divided by a half, so you okay that this denominator is a half? That's the same as taking the top and multiplying by the reciprocal of the bottom. You good now? 2 points. Anybody else? Cool. Okay, at this junction, there's nothing left to do really except arithmetic, multiplying, square rooting, that sort of thing. So it becomes, I'll be honest, sometimes it can become tedious, but the calculus is over. We're just plugging in numbers. So we go 2, so plug in, this is square root, so plug in an 8. Questions? This is kind of just a little thing to make the memory more permanent. Go ahead, please.
Alright,
You're good.
so you have equal signs down, like the lines. Like when you start doing the plug-in, you still want to say that that's all equal to like that equation.
Because it is.
Is it because you have the bar that has the 8 and 0?
Uh-huh.
So okay.
Yeah. In fact, I'm going to give 5 points to every single person in the room right now if you're willing to do the following. It ties directly to what Brennan just said. This integral is equal to each of these things. Just straight down the line. So this integral's value is 4. So grab your calculator, type it in and just see for yourself that the integral's value is 4. I'll give you 5 points for doing it. It's kind of simple, but it really reinforces the memory to literally just do it and see that, hey, that's the same thing we've been doing. We just did it without the calculator. So.
How do you plug in the derivative and integral at the same time?
This one we don't need to plug in both. We're just doing this integral.
Oh.
This is how it looks on your calculator.
Oh.
No worries.
Okay. Sorry.
You're good. If you can't get it to work, ask me, I'll help. How many got to work? Show me hands. How many got to work? 5 points. Good work. Please, have it.
Where did the C go?
Oh, yes, my apologies. Hey, look. So, when you're doing this process, the grader does not expect you to write C, and here's why. This would have been plus C, correct? So then there'd be a plus C right here. Then there would have also been, let me help, let's write it out. 2 for Hadley. We would have had plus C, subtract. And because we're subtracting 2 things, we've got to have a parenthesis. So then you'd have 2.
Oh, then it's
Do you see it? Like that. Okay? When I distribute the negative, this C becomes, wait a minute, I messed up. That's plus, sorry. When I distribute the negative, this becomes subtract, so the C's just subtract away. So no one expects you to write them.
Cool.
Anybody else? Please.
Will that always happen?
Because what's always going to occur is when I'm finding the integral, remember, I'm thinking of this as f prime. And so I've got to find f. So f is the green, plus a constant always. And whenever I start plugging in, I'm always taking f plus the constant, subtract f plus the constant.
Okay.
So the subtraction always gets rid of the c.
So why do we have a C?
It'll show up in some future stuff. We just aren't quite there yet. But it will show up. So, 2 points. Anybody else? Next one. Write down number 2. You don't need to write out the whole problem. Number 2 asks you to find the average value of this function over that interval. So all I need you to write in your notebook is what integral is needed to find this average. So write it down. Go. What integral do you write in the notebook so that you can find the average of that function over that interval? Okay. Show me your hand if you have this written on your paper, please. 2 points. Question? You want me to explain anything? So this is how we find an average, straight off the last test. We good there? All that's new today is no calculator. So yeah, it's more writing. You can just plug it in, you'd be done. Okay, first thing, I don't worry about the fraction out front, just bring it along. It's just the fraction is 1/3. Okay, right here, look, focus. Okay, when you have two things being added or subtracted, we can find the antiderivative separately. So I want you to get a little, I want you to get good at doing a little more in your head, because it does, actually in this case, prevent some mistakes. Writing all the steps gets to be a lot. So I'm just looking at this and thinking, okay, to find the value of this integral, this is my f prime, and I need to find out. So I think I can do it in my head, because let's see, 3 is just a constant, just stays right there. So the t cubed is going to become t to the 4th over 4. Wait if you need me to do that again. So for antiderivative, the t cubed is going to become t to the 4th over 4, and I'll still be multiplying by the 3. So on the next line, I can write one equal sign for sure, 1/3. Still have an integral. Oh, no, not anymore, because I'm finding the antiderivative. Sorry about that. So I'd have, let's see, the 1/3 gets multiplied by all of it, so I need a parenthesis. And I would have 3 t to the 4th divided by 4. I can show more detail if you need me to. Just wave. Then it's subtract. Okay, t squared, t cubed over 3. Wave if you need me to do more. Okay, so let's see, t cubed over 3. And then all of that needs to be evaluated from -1 to 2. The 1/3 is just an extra multiplier. So right here, this is my f. We take the derivative of the green, we get the orange. You can see it. Bring down the 4. 4's divide out. You're left with 3t cubed. Take the derivative of this one, bring down the 3. The 3's divide out. You're left with t squared. So here's f prime. This is f. Or if you like, this is f double prime, and this is f. Doesn't really matter. Okay, we'll see some problems in the future. Don't miss this one, where they'll refer to this as small f and this as capital F. Okay, that's not standard notation, but it is very common on the AP test to think of the antiderivative of f as capital F. So, questions? Brennan, please.
I just have a question, like with the integral sign. So like now that we're doing it, we have it like 0 to 8 or like -1 to 2, but like on the last stuff and like on number 3 on this, it just has like the little s. Like, does that give you a domain, or does that just mean for all?
Oh, gotcha.
Like or does that just mean do the antiderivative? Like, what does that mean?
I understand. 1 second. So you're looking at like this one.
Yeah, like what's the little s?
Gotcha.
First with numbers and without.
Okay, everybody look. 2 for Brennan. Look up. Sorry, I got something in my eye. Okay. When there are no limits, it's strictly an antiderivative. So all you're doing is saying, I need to find the antiderivative of this. I'm just using the rules, or doing a u substitution and then using the rules. That's all. When it has limits, it's an integral, which you could plug in your calculator if you wanted to, if it was legal. Or we have to use the fundamental theorem, like we're doing today. So we have to remember that, okay, right, to find this, I've got to remember that the integral from -1 to 2 of, I'll use small f this time, has got to equal capital F evaluated between -1 and 2, where capital F is the antiderivative of small f. Does that answer your question?
Yeah, so it's integral, like what you said, when it doesn't have limits, we just find the integral. Is that the same thing as the antiderivative?
Yes.
Okay.
Yeah, so when you see this symbol, there's several different ways of saying it. Some people say this is the integral, but they mean antiderivative because there's no limits. Some people would say this is the indefinite integral. No limits, it's just an antiderivative. Is that your question?
Yeah.
2 points. Anybody else? Cool. So back to here. So we found f. We're evaluating f. So we're at this stage in the fundamental theorem. Now it's just plug and chug. So go. Stop me if you have a question. Now it is a test of patience and arithmetic. So, perseverance, persistence, grit, determination. Good question. I think it's best to leave the 1/3 factored out. I think it's less prone to mistake. So I just say, okay, this is going to be 1/3, and that's all multiplied by, and I start plugging in. So plug in the 2. One caution. I now need to subtract 2 separate terms, so don't forget the extra parenthesis. So your work should look exactly like that. Everybody look at the board for a moment. Okay. Just a little trick that you don't always notice without someone showing you. When you're doing all this arithmetic, you always have junk minus junk. Okay? But the junk here is very similar to the junk here because they came from the same formula. So I don't really look to combine these two always. I look to combine, in this case it didn't really help, but these two here, because they're coming from the same formula. So I'm looking to see how these two will combine and how these two will combine. Part of it worked beautifully because I've got -8/3 added to -1/3, so that becomes -9/3.
It's -1/3, but like I thought, so -1 to the cubed is a negative and it's a minus, so it just goes positive.
Doing great. So this would be -1/3 here, right?
But
the negative must distribute. So it's, okay, I'm messing you up. Hold on a second.
So we change the positive and then go back to negative?
There we go. So -3 cubed is negative. Multiplied by this negative makes it positive. When I distribute, it goes back to negative. Comfortable?
Yeah, I got it.
You're good. Super Ben. okay here?
Yeah.
You okay here?
Well, no, how come that is?
Oh, not plus, gotcha, is that what you're saying? My bad. Right here, help me. So what's negative 1 cubed? So this would be negative 1/3. So that would become positive 1/3. But because we're subtracting all of it,
Oh, it changes.
the negative has to distribute. So it goes back to negative. Good question.
Sorry, I used some letter.
Oh, don't even worry, Nathan. No big deal. Keep asking. Please, Ashley.
Wait, how did you get from where the arrow points from 12 minus 9 thirds minus 3/4 to the other one?
From here to here.
Yeah.
So it isn't.
So what's 9 divided by 3? Good. So you've got 12 plus negative 3. You good? Good question.
Well, that's what there's 7. See,
Anybody? Ask anything you want. I want you to be comfortable with it. Anything you see that like your brain says I don't understand, just wait. Which one? From here to here. So I'll let you think through it. It'll stick better. What's 9 divided by 3? Good. So you got 12 plus negative 3.
So 9.
So 9.
Oh, very good.
Anyone else? Cool, next one. Write down number 4, please. So again, we're using the fundamental theorems. So I'm using this. This is my f prime. Doesn't literally mean that it's f prime, but it's just how I kind of think of using the theorem. So, question? Cool. Okay, the bad news is, I'll be honest with you, there's no formula that fits that. There's no simple algebra trick, so we have to do U substitution. Yeah, I know. I'm on your side. There's no way around it. That's part of the AP test. So, let's see. Square root though is problematic, so I change it to a power. So write down. Let's see, 0 to 1/2.
Or is it because it's not ax plus b?
Right. It's squared. Well, there's two problems actually, Brennan. The 2x in the numerator makes it so that extended rule won't work. The x squared additionally makes it so the extended rule won't work. So this becomes 2x divided by 1 minus x squared oops, come on, brain, dx. So now that's my f prime here.
Where'd the x come in?
One half on the outside.
That would help. How many saw that error? 2 points.
Just why is your back?
I love how Tessa holds her backpack.
Okay. Please.
Is it easier to move that to the top and say 1 minus x squared to the negative 1/2?
Yeah, the reason is, hey, 2 for Rachel. The reason you want to move it is you don't have a rule that allows you to do, 1 over stuff to a power. So you get the power in the numerator so you're closer to the power rule. So that's still my, keep changing colors here, but that's still my f prime here. I've got to find f. Questions? Okay, so because it's U substitution, I must first identify two functions that are being multiplied. So don't think too long, just raise your hand when you can see the two functions that are being multiplied. You can see the two functions that are being multiplied. Don't get points unless you have your hand raised. It's hard to kind of check after you're thinking with me. So Grant, what are the two functions that are multiplied?
2x and 1 minus x squared to the negative 1/2.
How many saw it? 2 points, perfect. The 2 being a constant, I'll typically pull that out. Let's do it with the same color here, hold on. So I have 2, 0 to 1/2. One of the functions is x. The other of the two multiplying functions is 1 minus x squared raised to the negative 1/2. So next step in U substitution is to come over to this side of the paper and select my two values that U could be. Okay, this is something to the first power. U is always the something. So we put an x right there. The other example is this is 1 minus x squared to the negative 1/2. So again, it's something to a power. My choice of U is always the something. Somebody yesterday came up with a way to remember that. They just latched onto the phrase, U is really something. U is really something. Please, Brendan.
So last time when we did U substitution, you said like you sometimes take the constant out, you sometimes don't. But like for this, like I can see that the derivative is going to be 2x, and that we would have had like 2x dx, and so I could like make that work without pulling it out. So would it change the answer?
Either way. Nope, either way. It's totally fine. 2 points. Pretty good? Oh, please.
So, I know I'm going to
You're super close. Just stay put. We'll get there. You're really good. Very good. I think you made one tiny error, but nothing big. Very good. Cool. Okay. Oh, I can't remember if I mentioned this in class or not. This is never a good choice. Like, it is a legal possibility, but it doesn't help, because if all I do is come over here and everywhere I see x, I write the letter U instead, I'll have exactly the same thing. So, not helpful.
Yeah.
So U is never going to do this. Apparently, speaking back grammatically helps the memory better, so we'll keep doing that. So, somebody remember the movie The Help? Yeah, please.
U is kind.
Yes.
U is fun. U is important.
There you go. U is something, you know. It's good. You'll remember better now. U is always the something, because U is something special. Yeah.
So when you said like knowing if you can C or not, like do we ever have to write C's if there's like limits?
Oh, gotcha.
Is that where we can?
Outstanding. Hey. No. If you're doing an integral, which means there are limits, you don't ever have to write the plus C, because it's always going to subtract out anyway. So no requirement to write plus C. Awesome. Let's see. Oh, it's U's and C's are probably don't. Okay, so I start substituting now. Oh, we need to do the test, and Brendan already did it. The derivative of this is negative 2x. Perfect. It matches the other function. Remember, the multiplying constant can be different, but the fact that this derivative is 2x is good news. Negative 2x. You need me to talk through that again? Just wave at me. In fact, here's a trick. All eyes on me. You're looking. James, look up for just a minute. You're good. Before I even start the problem, I've learned to test before I write down anything. So I looked at this and said, hey, wait a minute. The derivative of 1 minus x squared is 2x. negative 2x. So right away, I'm feeling pretty good about u substitution because I see that little connection. And that's true most of the time. So it's a really good, quick kind of clue that u substitution is going to work. So we plug it in over here. So this becomes 2, integrate from 0 to 1/2. See x. And Allie, there is something new on this problem. The way you did it is not illegal, but I'm going to have you switch to a slightly different method. Don't erase anything, just wait. Sorry. But you'll want to do this other method because it makes it possible to do some future problems. Be good here? Come over here. So now what I need to do is so I've substituted this one. I got to substitute for x dx. So I take the derivative of both sides. So u dx equals, that would be 0. This would be negative 2x. You always multiply the dx across. I'm going to divide the negative 2. So now I have that. You need me to talk more about that. Please, like.
So if the 2 on the integral, if that was a negative 2, could you just leave the negative 2 on that side and then set that whole thing?
Yeah, then you could just leave this as negative 2x dx, would replace all of it. It's perfect. The only difference really is a negative. So when I substitute again, I get, let's see, 2, 0 to 1/2, u to the negative 1/2, x dx. So in place of x dx, I have negative 1/2 du. I'm writing a lot. If you choose to skip a few things that I write, that's totally fine. Oh, let's do this real quick. I've seen students do this a lot. Why is that wrong? Why will you lose points? Show me. So I replaced x dx with negative 1/2 du. That seems okay, but if you write it this way, you will lose points. Why is that incorrect notation? So Maya?
Looks like it's subtracting correctly.
Looks like you're subtracting. You have to go like so. How many knew it? 2 points. Okay. Question? Awesome. This is a multiplying constant, so it can come out. When these two multiply, this becomes negative 1. This is getting to be a lot of writing. That's the way it goes. So this is negative 1, 0 to 1/2, u to the negative 1/2 du. Okay. There is one additional new step here. If you remember back to when we first started talking about integrals, I would always write this to remind you that those are x values. Okay? Well, we are trying to convert everything to u values. So I don't want x's here. It's not legal. They need to be values of u. Well, all of the changes occur based on one formula. So look, I used this formula to replace 1 minus x squared with u. Then I took the derivative of this formula, rearranged, and replaced x squared dx with negative 1/2 du. So all of the replacements are based on this formula. So I need to do one more replacement. Let's see, we got u equals 1 minus x squared. I need to replace the limits. So just plug them in. So u is equal to 1 subtract, when the x is 1/2. That's going to equal 1 subtract 1/4, or 3/4. You would need me to talk through the y of that. Hadley?
So you're just replacing the limits because those limits are x and then the new limits for u?
Correct. We want to convert everything from x to u. Perfect. 2 points for Hadley. Cool. I need to flip the other one. I'm sorry, change the other limit as well. So u is equal to 1 minus, let's go 0 squared, that's equal to 1. Cool. So now we have a brand new transformed integral. You all wish you had magic paper too that just keeps scrolling, just keeps sliding as much as I want. That was dumb. Okay. So we got -1. Make sure you put the limits in the right places, even if it feels awkward. When u is equal to, oh, that's x. Who wrote that? Who saw that mistake? 2 points. These are still x's. Still feel like I'm in that movie, The Help. So these are x's. Now we have values of u. When x is 1/2, u is 3/4. When x is 0, u is 1. That seems backwards, but we have to use equality, so it has to be that way. Please.
How did you get -1?
So the -1 occurred right here. I replaced x dx with what it's equivalent to, du over 2. So -2.
Oh, I see what I was doing.
See now?
Yeah.
2 points for Mike, please. Zach.
So on the last two steps we just did, how can you say that that integral with the 1/2 and the 0 is equal to the same thing with different values? Do you have to write x equals and u equals?
Gotcha. Let me say back to you what I think you're saying, because I think it's a superb question. 3 points, 4, 5, mark them down. No, really, it's a really good question. It's really good. It's right on point. It's very good. I think you're saying that, wait a minute, how can this integral be equal to this one when these are x's and these are u? Like these two here especially, right?
Yeah, because you just changed numbers in it and said they're equal.
Right. Absolutely correct. To be strictly accurate, you would have to do exactly what you said. As you're working your way down through here, you'd have to say, no, wait a minute, these are x values, now they're changing to u's to really make the equal strictly correct. The graders are okay if you don't. So, but what, does you see what I mean?
Yeah.
Yeah, your thinking is awesome, because that's exactly the right idea. But the graders don't, it's okay, it's accepted that you're just in the process of making the change. So they're okay to not do that. Does that answer your question?
Yes.
Perfect.
Right along the same lines, why wouldn't you change the limits to the u values right where you switch x for u?
Honestly, that would fix both problems. Like, well, it still doesn't because it's still kind of all messed up as you're writing it. You can change it anytime you want. Like if you decide, hey, right at the beginning, I'm just going to change the limits because I know I have to eventually, that's fine.
Okay.
So it doesn't really matter where.
And with that, you'll probably get to this, but when you switch back to x, would you change the limits back to x?
2 more for Rachel. When we are finding an antiderivative, this goes back to Brennan's question as well. When you're finding an antiderivative, so you don't have any limits, and you do a u substitution at the very end, you switch back, like the last step. When doing an integral, we don't. We just stay with u. It's just easier. So it's actually legal to do it either way, but you'd have to switch the limits back
That's
again.
just more work.
Just better to stay here. So.
Like, so when we're doing this problem to find the value of the integral, we don't plug in the 1 minus x squared again?
Correct.
Okay.
You actually can. There are 2 ways legally to work the problem, but I don't want you plugging it back in because there are AP questions that force you to do it this way. And if you don't understand this method, you just won't know what you're supposed to do, even though both methods are legal. So I have to teach you this method so you can answer those AP questions. That's all. I actually in college learned the other way, and I never took the AP test, so it didn't hurt me. But the first time I saw that AP question, I'm like, what? I myself was kind of stuck. I'm like, what are they asking? But I figured out they had done it this method, so please. The other method is to switch back to this. Like once you found the antiderivative, plug this back in and use the original limits. Don't do it that way. You'll have trouble in future AP questions. Just go this way. Cool. 2 for Hayden. All right. The antiderivative now is pretty simple. Because it's just u to the negative 1/2, so it's just the power rule. So it becomes u to the negative 1/2 plus 1, which is 1/2 over a half. Same thing as multiplying by 2. So we're going to end up with negative 1. Oh, I want to do one more thing. I'm sorry. My bad. This is my fault. I need to introduce one other concept. It's really simple. Okay, these limits are backwards, right? There's nothing wrong with that. We just followed the equality. That's exactly what we got. But if you'd like, this is your option. You don't have to. You can switch the limits as long as you multiply the entire integral by -1, and they're equivalent. So anytime you want, you can switch limits, multiply by a negative, it's the same thing. So I'm going to do that just to introduce that idea. So this becomes, let's see, 3/4 to 1. When I multiplied by -1, the negative became positive. U to the negative 1/2 du. Now I do the antiderivative, so I get, let's see, u to the negative 1/2 plus 1, all over negative 1/2 plus 1, from 1 to 3/4. That becomes 2 square root of u, 3/4 to 1. Outstanding concentration today.
So when you switch the limits, you only do it when the top one is less than the bottom one?
Yeah, that'd be the only reason I would typically do it, is just to put the limits in order. But it's not even required. That it will work just as well to not switch them. Avery,
So when you want to switch the limits, you just multiply the whole thing by negative.
by -1.
Oh,
Point.
is that why your negative 1 dropped out?
Right. Because when I switched the limits, I multiplied all this by -1, that became positive. But it is valid either way.
What's the benefit?
No benefit in this case. There are some future problems where I do think it is beneficial, so that's why I introduced the idea. Just took advantage of it happened, so I just thought I'd show you. Cool. So keep going here. So this is 2 square root of 1, subtract 2 square root of 3/4. That's equal to 2 subtract 2 root 3 over root 4. Root 4 is simply 2. So you get 2 subtract 2 root 3 over 2. I have to say 2 one more time. There we go. Perfect. Question. Please.
If we had done it when we did plugged in the 1 minus x squared for the u, we would have gotten the same answer.
So right here, if you leave the limits alone, find the antiderivative. So jump over to, say here, put in the 1 minus x squared, and leave the limits at 0 and 1/2, the exact same answer. Is that your question?
Yeah.
2 points.
What about that negative when you have it
Right here. So what I did, and you didn't have to, I'm just illustrating a concept that you will need in the future. I said, I'm going to switch these limits. So whenever you switch the limits, you must multiply the integral by -1. So -1 times -1 becomes +1. Is that your question? 2 points for Isaac. Please, Nate.
I'm so confused on the 2 square root of u.
Right here.
Yeah, so like what above negative?
No worries. Are you good there?
Yeah.
So what I did there is I said, okay, wait a minute, this is u to the 1, I'm just going to do it down here, is that okay? So I got u to the 1/2 divided by 1/2. Okay with that? U to the 1/2 is square root of u. So when you divide by a fraction, it's the same thing as multiplying by the fraction's reciprocal. 2 root u. Point. Anybody else? Oh, please have.
How come you can like still solve for the whatever the value is without putting in like the x? Does that make sense?
Got it. Outstanding question. Hey, I'll let like everybody look. Hey, look. I'm hoping this will click without me actually writing anything. Okay. What happens is we just do the exact same operation in a different sequence. So what we did is we set, so like let's say that we find our antiderivative right here, 2 square root of u. And if that at that moment we could take this and plug it in. And then we'd have the 2 limits, right? So the limits would get plugged into that thing. Well, all we did was plug in the limits earlier. So we plug them in, change them to u limits. That way you don't have to go back. That didn't help you very much. Yeah, mathematically it's exactly the same thing. I have to write it out. Hold on. Let me get through the next example. Then I will be glad to come back for those who want to see and write them side by side and show you that it really is the same thing, just in a different sequence. You just can't see it in your head without me writing it. Is that okay? Okay. Any other questions here? Please.
How do I get that if I didn't switch the limits because I had the negative, or whatever, I had the positive square root of 3 in the front?
So you had root 3 minus 2?
Like I didn't switch it, and so I
understand.
Yeah.
You just made a sign error. I'll have to come look at your work. I'll find it. Yeah, give me a second. I'll come find it for you, Brent. So it really does come out exactly the same. Next one. Please do number 5 yourself. Go. Do number 5. Go. Oh, that's the I'm sorry. That's the wrong sentence. Okay, just straight line. That's there. You're fine. That's good. Here's perfect. All you're doing is you forgot what that means. So 4 to the 3 halves means take the square root of 4, which is 1, and take 2 and cube it. Nothing's wrong. Really good notation also. Oh yeah, sorry. It looks okay. This is right there. Hold on a second. Oh, so if you change back to x, the limits have to stay x.
So there's that.
Does that make sense?
Yeah. Okay. Well, like I think about that, and when I tried to put it, but then I didn't. So I didn't get the x. I didn't put this in. I just put it in the.
Oh, right.
That's it. Like, yeah, but I'm sorry. I guess this is you still. So like, I guess I could just get rid of this one.
That's good.
So I didn't just use.
Oh, I see. I got
I
you.
didn't switch it.
So wait, so the difference is you put a negative there is no negative. Oh, wait, there is a negative. Oh, you're there we go. So they have this, that's awesome.
This is supposed to be negative.
Negative there.
Minus negative.
Yep.
So I
That's negative, that's positive. It's the same thing. Because I had 2 subtractions.
Okay.
Does that make sense?
Yep.
Every time.
They won't get points for that next more than in class. So, correct.
Maddie.
Yeah, that's a harsh one.
I cannot wrap my head. If you have something over 3 halves, and it's multiplied by 3 halves, multiplied by 2 thirds. You flip it.
You're dividing fractions, right? So you have the fractions in it, like, whatever, the numerator divided by 3 halves, right?
Yeah.
And so when you do that, you flip the second multiply, right? Through the numerator times 2/3.
This one.
Right?
Yeah.
Dx instead of dt.
Yeah, because wait, when you divide a fraction, you multiply by their
And
reciprocal.
then
And then,
Yeah.
oh, you do it again, you
upside down.
do the reciprocal twice because, yes, I get it now, sorry, I get it.
See what happens and then.
Have some fun.
I don't see the last
I think that's specific enough.
Usually because the signs are the same.
Kind of like.
Close. I think you can get 1 out of 62. I worried that
And then you just
I might pick
you just look forward to doing the math arithmetic after you figure it
something to the where 3 halves, that one is wait, how, is something to the root of 3 halves squared 3 halves?
So, you cut out when it's 1/2 of a square. So the bottom one is like substitution, yeah. The top one is like, I remember that.
And then
What's the first step?
Like I took.
So was your struggle trying to do math? How do you do math?
The bottom one goes through the other two, like if you have a root, you know how it's. So this one's 2. And then you take the top one and you put like the number inside. So like you do that with your square root. You can take it as it wants. You can just say it.
That's what you have, right?
Okay, so top 3 goes with this. Top number wait. Okay, and you wouldn't see that if it's okay, but then the
number 5 is on the board.
the 2 is the square, so you don't.
Please, like.
How did you do 4 to the 3 halves? Like,
Oh, gotcha, yeah. Okay, right here. Look, super good question. It's asked every year. It's one of those things doesn't seem to stick in our brain. So up here, you get to choose. Look, this is going to happen repeatedly. It's a common AP question. Ready to look up in just a second. Ellie, you're good. So you can either do 4 cubed first, which is a bit hard. It's 4 times 4 times 4. Or you can do the square root of 4 first, which is 2. Then you take the 2 and now cube that.
so the bottom one is the square root and the top one is.
Top is the power, bottom is the root.
That makes sense.
Mr. Rucky has a good saying, power on high, root below like a tree. He does a big speech. Yeah, he does. So right here. So you get to choose the order, like the way Maya wrote it might help. So you can either do this. I can say, let's do 4 cubed. And then once I've found what 4 cubed is equal to, I'll take the square root. That's one legal way. 4 cubed turns out to be 64, and the square root of 64 is 8. So that works. But the alternate method is, let's do the square root of 4 first, and then we'll square it. Sorry, cube it, my bad. So the square root of 4 being 2, I end up with 2 cubed. also 8. Anybody else here? Good work today. I'll show the other thing right now. So, if you're interested in the whole U versus X thing, just come up to the front and I'll show you. Oh, please. Oh, you started. So that's where we were at, right? The other way would have been, you'd have the same antiderivative, but you would have put back in the 1 minus x squared. And this would still be negative because you haven't switched any limits. And this would go from 0 to 1/2. Okay with that? So here, we take 2, plug in the 1, subtract 2, plug in the 3/4. Here, negative 2, square root, 1 minus, now we're plugging in the 1/2, right? But notice 1/2 squared is 1/4, minus 1 is 1, that's 3/4. It's right there. You see it? Yeah, it's the same thing, just a different order.